today we are going to see addition of two 16-bit number, addition and subtraction, where the values are in internal memory, that is in the RAM in 8051 microcontroller. We will be doing this simulation using KEIL New Vision. This is the IDE, and I have already made another video where you can see if the values are stored in code memory, that is ROM, then how it will be done. That is more complex, and this one is easy. So what we need two numbers that will do addition and subtraction. Numbers are not 8-bit but 16-bit, so each number will have two parts. Suppose this is the number 5678, then this number will have, this is 2-byte number 16-bit, so the 78 is known as lower byte and 56 is known as higher byte. We will actually store this into two parts because the memory is each byte, each location has can store one byte memory, that is 8-bit. So this is, as this is 16-bit, so we have to divide it into two parts, lower byte and higher byte. So this 78 is lower byte and 56 is higher byte. Similarly for the number 234 is lower byte and 12 is higher byte. So we will be storing, as I have divided this number into this four parts. Number 1 lower byte, that we will store at 30H. Number 1 higher byte will be stored at 31H. Number 2 lower byte 32. Number 2 higher byte at 33. So this way we designate the memory, that is the RAM memory starts from 30H, general purpose memory 30H in 8051. So this will be the places where I will store the numbers that we need to add or subtract. So first number will be stored in 30 and 31, second number will be stored in 32 and 33 memory location. Similarly, the results will also be 16-bit. So the summation result will be stored in the lower byte in 40 and the higher bytes in 41, and subtraction results lower byte in 42 and higher bytes in 43. This is the memory where we will get the values and where we will store the results, this program. Now what we will do, the very basic thing, the algorithm for this addition is that you need to add, for addition you need to add the lower bytes first, add the lower bytes and check if there is a carry. Then lower byte, the result of addition of lower byte is the results lower byte, and for the higher bytes you add the higher bytes of the two number. Then if there was a carry in the earlier part, that is when you were adding the lower bytes, you get one carry, then add that carry also, then that will be the result. So for the first part you have to add simply, and in the second part when you are doing the higher bytes you have to use add C, add with carry, add C instruction. So for the lower bytes you have to simply use add, and higher bytes you have to use add C, add with carry. And while doing the subtraction, the algorithm is same. First do the subtraction in the lower bytes, that is number 1 lower byte minus number 2 lower byte, and also check if there is a borrow. Then do the same, number 1 higher byte minus number 2 higher bytes and minus borrow if there is a borrow. If there is no borrow, then nothing. And for this operation you have to use SUBB, subtract with borrow, that is the code or opcode instruction code. Now we'll see, we'll first build this one, build target, that is F7, or from project to build target. This is build done. Now we'll go to debug window. Okay, in the debug window, what in the memory I have opened D:0x30, that is a data section, that is the RAM internal memory section. D:0x30, that is a 30 memory location is shown here. So 31, what we can see, 30, 31, 32, 33, these are required, and also we need 42, 41, 42, 43 to see the results. So first we need to store the values. So what we'll do, move number 1L has 78, that is in the number 1L position, number 1L position is equal to 30H. So that is basically move 30H comma 70 has 78, that is store the value 78H directly in memory location 30H. This line means that. So we can write this way, or this is easy to understand. Otherwise we can write, we could have write move 30H comma has 78H, that is store this 78H value in memory location 30H. So both way you can do. So let's execute this line. So you see that 78 is loaded. Now we load rest of the numbers. Okay, all numbers are loaded. So first number is 5678, another number is 1234. Okay, now we are going to add. So for adding, what we will do, first add the lower bytes. So 5678, 78 is the lower byte of the first number, and 1234, this 34 is the lower byte of the second number. So we will first load this 78 value to accumulator, then from accumulator to another register. So first do this. So now register R4 contains the value 78. Now we load this 334 in accumulator, that is the second number's lower bytes. So okay, done. Accumulator is loaded with 34. Now simply we'll add accumulator and R4. So add A comma R4. This will add the lower bytes, that is 78 and 34. We will get AC. So let's add. Add is done. We see accumulator contain AC. Now we move this value, that is AC, to sum, that is the result. Sum L contains the lower byte of the result. So lower bytes are added. So we move the accumulator result into sum L. So as soon as we do this, this will go to 40. So 40 is the resultant sums lower bytes. Yet now we have to go for higher byte. So we need to add higher bytes and check if there is a carry. As we see, there is no carry in the first part. First byte, that is not more than FF, result is not more than FF, so there is no carry. So carry is 0. But still we check this if there is a carry and store in R6. So these two lines are to check if there is a carry. JNC means if there is no carry, go to no carry level, and if there is a carry, then increment R6. So as there is no carry, it will directly go to no carry level. INC R6 is not executed. Now what we do, we now first move in the now second numbers higher bytes in accumulator, then store it in R4, then the another number in accumulator, then simply add the higher byte. So now one higher byte is stored in R4 and another number's higher byte is now stored in accumulator, 12 and 56. Now we need to add them, but instead of add we need to use add with carry, because for this case there is no carry, carry is 0, but this may happen that in the first when we are adding the lower bytes, it may generate a carry. So we need to consider that, because while we are adding the higher bytes, we need to add number 1 high plus number 2 high plus carry. So if there was a carry, then we need to add the carry, then we will get the result in the accumulator. So we are doing add C, we get 68 in the accumulator. Now we are storing this in sum H1, means resulting sum higher bytes. So 68. So the result of summation is 68 AC. Now we'll go for subtraction. The same way we will load the first number, one number, then store it in R4, then load the second number, store it in accumulator, then we do the subtraction. Before that we need to clear the carry, make the carry 0. Why? Because if there was a carry beforehand, then that would impact the subtraction. This is from basic binary algebra. So we clear the carry, then SUBB A comma R4, that is it will subtract the value of A is 78 and R4 is 34. So 78 minus 34. This will be done. In this case, no carry will be generated, so only the result of 44 is coming to accumulator. Now moving the accumulator value to diff L, that is containing the result of the subtraction lower bytes. So this will be this location 42. So this will go to this location 44. Now we need to find the results of subtraction of the higher bytes. So again we load the second number in accumulator, then from accumulator to R4, then load the first number in accumulator. So now accumulator contains the first number 56 and the R4 contains the second number, that is 12. Now we're doing 56 minus 12. SUBB A minus R4. So result will be again 44. So as soon as I execute this one, result is accumulator contain 44. No borrow generated. Now this result is the higher byte. So it will be moved to 43 location. So execute this is 44. So subtraction result is 44 4 44 4 4 4 4. So this is how it is done. Now what I will request for your good understanding, I have done the most simplest case. What you can do, you can change the numbers so that during addition you get some carry, during addition of the lower byte you get some encounter some carry, and then you can test this one, that while add C, you are doing add C, then there is number 1 high plus number 2 high plus carry. This is happening or not. You can verify this one. Again similarly, during subtraction you take the first number lower than the second number, at least the lower bytes, so it should generate some borrow. If then you can see in the higher bytes if the borrow is also subtracted or not. That is, while you are doing the subtraction, you can see in the higher byte number 1 high minus number 2 high minus borrow. This is happening or not, you can check. Also you can check in the PSW carry and auxiliary carry bits, this will become 1. So this you can do, and if you face any problem doing this, you can comment and I will try to answer that. Thank you.